Welcome to Study Loop.
For each of the following states, to figure out what point in the probability distribution the function is maximum, we first write out the wave function for a particle in a three-dimensional box. So psi is equal to 2 over L, where L is the length of the box, to the 3 halves, times the sine of n sub x pi x over L, and then the same thing for ny and the same thing for nz. So I'm using the notation here where S is just short for sine. I got this from a particle physics teacher of mine, and it really shortens up some of the notation when you're writing these really long equations in particle physics and quantum mechanics. So I show the notation here. So sine of something in parentheses is equal to S of something in parentheses, just some shorthand. So the probability distribution function is equal to the absolute value of the wave function squared. So that would be equal to this here. So each sine value gets squared, and the 2 over L is now raised to the third. The 1/2 value is canceled out. So to determine what value of x, y, and z causes the probability distribution function to be maximum, notice that the function will have a maximum value when all the sine values are equal to plus or minus 1. Plus or minus because the values are squared, so the negative signs are going to cancel. So let's go ahead and type that out. So the function is maximum when all the sine functions, wave function here, wave function is maximum when all sine functions are equal to plus minus 1. Okay, so let's just consider one of the dimensions. So for A, we have nx, ny, and equals nz all equal to 1. So for just one of the values, if we have the sine, say, x, so this would be x times I x over L is equal to plus or minus 1. Values on the unit circle give plus or minus 1 when we take the sign of those values. Well, it's pi over 2 in all iterations of pi over 2. So therefore, from this, we know that n sub x pi over L has to be to integer value of 2 because we're going to get plus or minus 1. So for the integer, sum k times pi over 2. Okay, so the values of x that cause sine n pi x over L to be equal to plus or minus 1 can now be solved for using this, because we know n sub x is equal to 1. So if we plug in n sub x equal to 1 and we solve for x, we find that x is equal to L over 2 times k. Again, when n sub x is equal to 1 in that equation, because the pi is equal. So we can go ahead and cancel pi's. Okay. So recall, though, that in the x direction, the box runs from 0 to L. So the only value that's allowed is k equals 1 to give this information. So k equals 1 to satisfy that this is greater than or equal to 0, but less than or equal to. So that confines it to that. Okay, so if k is equal to 1, that means x is equal to L over 2. But since nx, ny, and nz all are equal, so we can say since n sub x, n sub y, and n sub z are all equal to 1, we know that x is equal to L over 2, y is equal to L over 2, and z is equal to L over 2. And that is our solution for. So next, for part, it's going to be the exact same thing for this time. Nx and ny are equal to 2, and nz is equal to. So again, we're using the exact same method, except for this time, k can be equal to 1 as well as being equal to 3 for x and y. So we can say nx and ny is equal to 2. We have and the same method as above. We're going to get the exact same solution, except for this time, nx and ny are different values. So you're going to end up with x is equal to KL over 4. Where k can be equal to, so this is also going to be the same for y, so it's equal to KL over 4 equal to y, or k is equal to 1. But z is still confined to the same confine above, so z is equal to L over 2. So our possible solution behind z, there's going to be several possible solutions. One of them, k is equal for x and y, so this gives L over 4, 2. And the permutation. So you have when k is equal to 1 for x, but k is equal to 3 for y, this gives you L over 2 over 2. Now you can do, then you also have of L over 2 for x, have k is equal to k is equal to 3, so this gives you L over 2, L over 4, 2. And then lastly, you have when both of them are equal. So you have L over 2, L over 2 for all. So we mix all of this in, solution for part B.